Hello and welcome to Tech by Dr. Blood. Today we're going to be reviewing abstract data types, a key component in your mastery for data structures and algorithms. We begin our discussion by first pointing out abstract data types can be abbreviated, commonly known as ADTs. So the ADT is a data type. It's really described by these predefined operations that don't give you much explanation. Working with a particular data set and you know that you need to insert some data at the rear or perhaps add some data to the front of it. You are going to use those predefined operations, perhaps just by using the name of the data set with a dot. So maybe a dot add or a dot remove to make that work for you, to get the data in the correct spot for you. Example operations might include append, remove, search, or print. What are the applications of these? It helps to think about this from an abstraction point, which means we are going to have the user interact with a high level. And it's not, the user's not going to worry about the complicated code underneath, the minutia, all those details of making the operation happen. That's all going to be hidden from the user. They're just going to be provided with that dot function so that they can get the job done. It supports this abstraction by hiding the underlying implementation details and just giving you the well-defined operations. The black box idea is that you tell the system what you're starting with. You have an idea of what you want at the end, but you don't really care how it's getting done. You don't know necessarily what the underlying data structure is or what sort of code's happening. It's just doing the work for you. And this enables programmers to focus on the higher level operations, the task at hand, maybe with working with algorithms, instead of having to write each line of code and take care of all the bugs that come along with doing that. Here's a list of ADTs, very common ones that we're going to discuss in this lecture. However, know that it's not exhaustive. There are plenty of others. The first one that comes to mind is a list. And while I am looking at this from a Python point of view, it's important to note that it's not Python specific. You will see ADTs in all kinds of languages, C++, Java, whatever the case may be. I'm just more familiar with Python. So the list is likely to be implemented using the underlying data structure of an array or a linked list. Lists are indexed beginning at 0. And it's all about holding that ordered pairs, the ordered data. They have operations such as append a data item, remove a data item, or search whether a data item exists. You can even print. We're talking about how these things simplify life. If I'm writing a Python program and I'm working with a data structure and would like to change the sort order, that can be a fair amount of code. We can write a lot of code to make that happen versus having the list ADT is going to allow me to do it very quickly and presumably efficiently. Next up is the dynamic array. And similar to a list, it's used for holding ordered data and allowing indexed access starting at element 0. The difference between the dynamic array and an array, which by the way is the underlying data structure, is with Python, you must create the array with a predefined size. So if you try to exceed that size, you're going to have a problem. You need to create a new array with a larger size, and that is a manual process that involves the system finding a larger spot in memory with contiguous space available for the new larger array, and then copying all the information from the old to the new before it can use it. Very efficient with the dynamic array because it takes care of all that for you. The Advantages in using this. Well, one, of course, like I said, to be able to resize the array as necessary, but having all of these fancy options. If we want to prepend an operation to an array, as it stands right now, we would have to move all of the information so that we can add a new or update the information at element 0. But our prepend operation for the dynamic array finds the information, determines if the array needs to be lengthened. If so, it's going to be resized. And then it's going to move all elements up by one position so that the element 0 is now available to be updated. And if we were wanting to remove an item, same kind of thing, just in reverse. We're going to look at each item after index 0 and move it down by one position. A stack is similar to a stack of plates. If you're putting away plates in your home, the general rule is that the last plate that goes onto the stack is also going to be the first one out. That poor plate on top is the one that's used all the time. The one at the bottom is only being used for Thanksgiving dinner. This is an ADT that's built on top of a linked list. By the way, that philosophy is the last in, first out principle. And operations, a sample of operations could include push, pop, and peek. Why would we ever use this? The item that comes to mind for me is always the undo operation. If you're ever working in Excel or a graphics program and you have those oopsie moments, it's nice to be able to hit Control Z or just hit the undo button to reverse what you've just done. And that's done by keeping track of all of those keystrokes, mouse clicks, things that you've done in some sort of a data structure. And it's just piled on top of each other, one action on top of another. So when you hit undo, it says, what was the last action you've done? Use it, undo it. If you need another one, use the next one, use the next one. If you do something new, it's going to put that back on the stack. So it's just stacking those plates right on top of each other. Here we're stacking all of your actions though. A queue, something that we're all familiar with because we've waited in line at the grocery store. This uses the first in, first out principle. First person that is in line is going to be the first one that gets waited on. The last person in line is going to be the last person to be waited on. Operations for this include NQ. So NQ means we're going to put somebody at the back of the line versus DQ means we're going to take somebody away from the front of the line. Next is the deque. Notice the spelling on this, it is DEQUE, and that's because it stands for a double-ended queue. Be careful, deck, a deck of cards, a stack of cards. Which one were we talking about? Well, it's not a deck in the sense of a stack, same kind of thing. It is a double-ended queue. Double-ended queue means that you are going to have a queue that you can push things to the front or the back, or you can remove from the front or the back. It is built on top of a linked list. When you're using it, you have to be specific with your operations. If you're pushing information to it, you have to say push front or push back. If you're working from you want to pull information off, is it pop front or pop back? Notice we have pop and we have peek. The difference, pop is going to actually take the information out of the data structure so that you can use it. But when we use peek, we're just looking at it. We're going to make the information available, but we're not removing it from the queue or stack or whatever operation you're working with. Added a couple other operations to this just as a point of interest to you that there are numerous operations that are available for all of the data structure. So check and see, is it empty? You can get the length of it. Plenty of information that you can get without having to write a great deal of code. A set and a bag. A bag is for storing unordered items, and duplicate items are allowed. If you're familiar with the game Scrabble, there are a number of little wooden blocks, each with a letter written on top of them. And all the letters get thrown into a bag, or maybe a couple hundred. You reach in, you get your letters, and you try to make words out of it. So we need to have duplicates for this. We need plenty of R's, S's, T's, L, N, E. That's right, those are the Wheel of Fortune letters, in case you're paying attention. Can't write many words without the duplicates. This is built on top of an array or a linked list. A set maintains the same idea. It's an unordered collection, but these are non-duplicated items, so they're unique items. You're only going to have one of each letter, which is going to be difficult to play Scrabble with. It's built on top of a binary search tree or a hash table. You may wonder, why are there two different data structures for this? With the array or linked list, having duplicates, not a problem. With a set, we want to take advantage of the fact that they are unique items. And by using the binary search tree or hash table, we're setting ourselves up for quickly being able to work with the data, for being able to search or update. Our binary search tree, our average is going to be an O of log n for going to be able to get the information from this, to be able to search from it. Whereas our hash table is going to be an O of 1 value. Very, very quick. Remember, this is unordered. So a set with 3, 7, and 9 is the same as 9, 3, and 7. Next up is the priority queue. A priority queue is set up where each item is given a priority, and the item with the highest priority is going to be closer to the front of the queue, whereas items at the lower priority are going to be at the back. And this is built on top of a heap data structure. We assign that priority value, but we have to be careful what that means. A high priority. In the ITIL world, a severity 1 incident is an incident in which maybe the entire network is shut down, where the data center has lost power, something that is absolutely mission critical. It's a bad day. Whereas a severity 4 incident could be something as trivial as a toner is a printer is out of toner in the graphics department. It can wait. It's not that big of a deal. So a 1 is a higher priority. Other incidents, a 10 might be more important. A heap, you have two different types. You have a min heap and a max heap. So a min heap would be useful for those where the lower number is the greater priority. A DEFCON 1 situation is much worse than a DEFCON 4 situation. This is done using the NQ operation and DQ operation, similar to, well, really the exact same as a regular queue. And here are some of the common operations for that. And then the last ADT that we'll talk about is the dictionary. Dictionary associates or maps, if you will, keys with values. Just like a printed dictionary, the key is the word, whereas the value is the definition. This works great with a hash table or a binary search tree. If our hash table is large enough, we're going to have a unique spot for each one of these. That's the idea. We don't generally have duplicate keys. Even in a printed dictionary, you may have words with multiple definitions, which is fine. You'll have a key with multiple values, but you won't have multiple identical keys. Some of the operations, maybe you're going to be looking up a value. Here here you could look up a value. Here you could set the value. Here you can delete. You can check to see if a key exists in the dictionary. Always important to look through and find out all the different operations that are available for you. This is great information for really optimizing your programming and making the most of your time. In conclusion, abstract data types are very useful in simplifying your code, making it where you can work on accomplishing your main task at hand without having to be a full-fledged programmer writing the details and all of the code blocks for the program itself. Applications, we frequently see this for algorithms, but it can really be any kind of a program that you're writing. It can just be because you're wanting to sort or maintain a collection of data. And of course, the examples that we covered range from the lists to queues and sets and priority queues and dictionaries. So plenty more of them. And I hope you'll use this information to further your knowledge. Thanks for watching Tech by Dr. Blood.